All right, let's sketch a couple of hyperbolas. Let's sketch a couple of hyperbolas. Now, I just want to create a distinction here. There's a difference between the word sketch and the word plot. When someone says to plot a graph, you are required to firstly create a table or generate a table of ordered pairs with a set number of x values, for example 5x values. You sub those into an equation and then you get 5y values, and then you take those and you create a set of ordered pairs with x and y's matching, and then you plot those 5 points on a Cartesian plane and connect them to make a graph. So we don't do a lot of that at the grade 10, 11, and 12 level. We focus mostly on sketching. So now for sketching, we don't care about that degree of accuracy you get from plotting. All we really care about is the shape. The shape has to be correct, meaning if it was a parabola, is it a happy face, smiley face? For hyperbola, if it's in the first and third quadrant or the second and fourth quadrant. We care about the intercepts. We care about the anything of relevance, any specific important points. We don't just care about a bunch of unimportant points. So let's see what's the process to sketching this. Okay, so the first thing is this -2 tells us something. Now if you've already watched the previous video, you should remember that -2 is your q value, which is your vertical shift. So it means we've moved our graph down 2 units. All right, it also means that that's our asymptote. Now let's start to figure out how we're gonna represent that on a Cartesian plane. We start off the same way we've always started off, with a y-axis and an x-axis. All right, so here's an x-axis and here's a y-axis. So now this -2 means that I'm gonna look for a -2 on my y-axis, and I'm gonna draw a dotted line. Now what is a dotted line? So a dotted line refers or depicts an asymptote. So in this case, my horizontal asymptote is at y is equal to -2. I also have a vertical asymptote. So for grade 10, it's always going to be straight down the middle. So you can just write x is equal to 0 along that line. So you know there's an asymptote there. Now when you sketch your graph, it'll have to be like in those portions. So we don't mind it crossing the axes, but it must never ever cross an asymptote. So if a graph crosses an asymptote, so if you decided to do that across this asymptote, immediately wrong. All right, it's not even just up for discussion. It must never cross an asymptote, because by definition an asymptote is a line that a graph never touches or crosses. Right, so now that we've just drawn our asymptote, let's check this bit here. Now this is going to give us the second bit of information. Our question we're going to ask is that, is this positive or negative? So clearly it's a positive, and from our notes on hyperbola, a graph that has a positive a value, that fraction at the front, goes into the first and third quadrants. So it should go over there, and it should go okay, so these might take a few attempts to draw because they're a bit tricky. It definitely takes me a few attempts to draw, but as long as it's something of an acceptable nature, we're good to go. So that clearly was not acceptable. I don't really know what I'm doing here. Okay, that's a bit better. Right, so that looks kind of nice. So now when sketching, remember we said we care about the shape. So my shape is obviously correct. I have a point of relevance. I have an asymptote. I just need one more point. Now which point? Oh wait, there is another point of relevance. what do you think it's going to be? What else is important about this graph right now? Yes, there's an x-intercept right here. There's an x-intercept. So I need to find that x-intercept. I need to give it to the examiner and say, yeah, there's an x-intercept here. Please, let me just mark it for you there, and he can give me that mark for that x-intercept. If there wasn't an x-intercept, I could have just chose a random x value, subbed it into my equation, found the y value, and just put it on the graph. But the x-intercept is there, so I need to figure it out. So the rule doesn't change. X-intercept, let y equal 0. So y equals 6 over x minus 2. So I'm gonna let y equal to 0. So that means 0 is equal to 6 over x minus 2. You should know how to solve an equation like this because you've done it before, but I'm gonna show you how you do this specific one, so maybe next time it can be a bit easier for you. So we start by moving your 2 across. That becomes a positive 2 and 6 over x. At this point we realize we can make this a 2 over 1, and we can cross multiply. So we put in equals, 2 times x is 2x and 6 times 1 is 6. Dividing both sides by 2, you get x is equal to 3. So my x-intercept is 3. So I can just put a 3 over there, and that should be done. That's pretty much done. Once I have a shape and 2 sort of points at least, I'm good to go. So for grade 10, you will not have any y-intercepts for your hyperbola. The reason being is because this asymptote is on the y-axis, so it'll never touch the y-axis. But from next year, this line will move as well. So for this year, you won't have a y-intercept for your hyperbola, but you will have an x-intercept. All right, so let's go on to this one. You should definitely pause the video at this point and try to work this out, because it's the same thing. It's the same idea, it's the same concept. It doesn't have any difference. Again, asymptote. So let's plot a dotted line at a y value of positive 1. So y is equal to 1. Also, just this dotted line doesn't really matter, but just refer that it's x equals to 0. This is your x-axis, this is your y-axis. We note that this is a negative, so our graph fits into quadrant 2 and quadrant 4. So somewhere there, and somewhere there. All right. I always can't get the one right. I don't know why. It's just really difficult, guys. It's a bit difficult. Okay, so we got a correct shape. We got a asymptote, so that counts as one relevant thing value. There's an x-intercept here, so again, x-intercept y equals 0. So we say 0 equals to negative 2 over x. At this point, let's associate the negative sign to the 2. So negative 2 over x plus 1 equals, then the 1 goes to the left and becomes negative 1. So you got negative 2 over x over 1 on the left, and then you cross multiply. So you can say negative 2 is equal to negative x. So x is equal to positive 2. Divide both sides by negative 1, and your answer goes there. Now, here's some food for thought at this point. If you found x is equal to 2, but your graph was like this and like that, you would have came to a bit of a problem. You can't put the x-intercept as negative as positive 2 here, because this is on the negative x-axis. So if this is a positive 2, your x-intercept should be on the positive x-axis, which is what we have here. Now, if you face something where you realize you're on the wrong axis as compared to your intercept, and you're certain this is correct, your diagram is wrong, there's a mistake somewhere. It's basically a point for you to reflect on your on your equation so far, and see if you've done everything correctly. Take a step back and try it again, because they should make sense. Your positive 2 is on the positive x-axis. All right, let's do one last one. Now, this is a bit of a curveball. This does not look like a standard function, and it's meant to throw you off. It's not very difficult because algebraically we can simplify it. Let's see how you would do that, and then you'll understand why this is a hyperbola. Chances are, looking at this, you might not be sure. You might find a straight line, or you don't know what you're going to do. All right, we don't know what we do in 10 situations, but this is how we can break it down. So this x over x, we're going to write that as one fraction and write this as one fraction. The same idea we use when dividing a binomial by a monomial. So this is equal to x over x minus 4 over x. And x over x just becomes 1. And so it's 1 minus 4 over x. Now, let's put this at the front. So this is minus 4 over x plus 1. And now we realize that we've got a hyperbola because there's an x on the denominator, and this is our q value. So we've taken this and written it in a way that's easy to follow, easy to understand. So let's see how we're gonna sketch it now, right? So clearly this is our asymptote. You know, you do your axis thingy, right? So you just do our axis, axes, our x and y axis. So y x, the plus 1, we can just yeah, just do that. All right, so this is y is equal to 1, and then we check now. All right, this is a negative, so second and fourth quadrant. Sorry, I'm forgetting to do my vertical here. So x is equal to 0. So I just said negative, so second and fourth quadrant. Okay, first time, guys. There you go. You find your x-intercept. So y equals 0. So let's do it from here. All right, so 0 is equal to negative 4 over x. So we said we're going to make this a negative on the top, plus 1. Move the 1 across. Negative 1 equals negative 4 over x over 1. Cross multiply. Negative x is equal to negative 4. Therefore, x has to equal to 4. And this is our point of 4. So we've got a shape, we've got a asymptote, and we've got a point. And we are done sketching.